Installing underground feeder wire and irrigation pipe is strictly prohibited by the National Electrical Code and other electrical codes. Irrigation pipe is not designed for electrical installations and poses a significant safety hazard. Irrigation pipe is typically made of polyvinyl chloride, which is not rated for electrical conductivity and can deteriorate over time when exposed to electricity. Irrigation pipe is designed to transport water and is not waterproof. Moisture can seep into the pipe and cause electrical shock or damage to the wiring. Underground feeder wire requires proper heat dissipation, which is not provided by irrigation pipe. This can lead to overheating and potential fire hazards. If underground electrical wiring is necessary, it must be installed in approved conduit such as rigid metal conduit, intermediate metal conduit, or electrical non-metallic tubing. These conduits provide proper protection for the wiring, prevent water penetration, and allow for adequate heat dissipation. If trenching is not feasible, consider these alternatives. Firstly, directional drilling. This method uses a specialized drill to bore a horizontal hole underground, allowing the underground feeder wire to be pulled through without digging a trench. Secondly, surface-mounted conduit. Installing the conduit on the surface of the ground, either above or below grade. This method requires more visible protection for the conduit. Thirdly, overhead wiring. If the wiring is only for low voltage lighting, consider installing overhead cables supported by poles or fixtures. This method is less invasive but requires careful planning and support. It is essential to follow established electrical codes and use approved materials for electrical installations. Installing underground feeder wire in irrigation pipe is not only unsafe but also violates code requirements. Explore alternative methods if trenching is not possible to ensure safety and compliance. Let's delve deeper into the reasons why using irrigation pipe for electrical wiring is a bad idea, according to electrical codes and safety standards. We'll also explore approved alternatives and best practices for underground electrical installations. Firstly, let's consider the materials involved. Irrigation pipes are usually made of polyvinyl chloride, which is a type of plastic. While polyvinyl chloride is durable and resistant to water, it's not designed to handle electrical currents or heat. Electrical conduits, on the other hand, are made of materials like steel or specialized plastics that can withstand high temperatures and provide a safe path for electrical wiring. The National Electrical Code specifically lists approved conduit types for different applications. Secondly, water penetration is a significant concern. Irrigation systems are designed to carry water, and while they might seem watertight, they are not designed to keep moisture away from electrical components. Any water that gets into the pipe can cause corrosion, short circuits, and potentially dangerous electrical shocks. Electrical conduits are designed to be watertight, or at least to minimize water entry, protecting the wiring inside. Thirdly, heat dissipation is crucial for electrical safety. When electricity flows through a wire, it generates heat. If this heat can't escape, it can cause the wire's insulation to melt or degrade, leading to short circuits and fire hazards. Electrical conduits are designed to allow heat to dissipate, preventing overheating. Irrigation pipes don't have this feature, so using them for electrical wiring can create a fire risk. Now let's explore some approved alternatives for underground electrical installations. One option is rigid metal conduit. This type of conduit is made of thick steel and provides excellent protection for electrical wiring. It's resistant to physical damage and can withstand harsh environmental conditions. Rigid metal conduit is typically used for underground installations where the wiring needs to be protected from heavy loads or potential impacts. Another option is intermediate metal conduit. Intermediate metal conduit is similar to rigid metal conduit but is lighter and easier to work with. It still provides good protection for electrical wiring and is suitable for a variety of underground applications. Electrical non-metallic tubing is a flexible plastic conduit that's often used for residential wiring. It's lightweight and easy to install, but it's not as strong as metal conduit. Electrical non-metallic tubing is typically used in locations where it won't be exposed to physical damage. If trenching is not feasible, there are still other options to consider. Directional drilling is a technique that allows you to install underground wiring without digging a trench. A specialized drill is used to create a horizontal hole underground, and the wiring is then pulled through the hole. Directional drilling is a good option when you need to avoid disturbing existing landscaping or underground utilities. Surface-mounted conduit is another alternative. This involves installing the conduit on the surface of the ground, either above or below grade. Surface-mounted conduit needs to be protected from physical damage, so it's often covered with a protective barrier. Overhead wiring is an option for low-voltage lighting. This involves running the wiring overhead, supported by poles or fixtures. Overhead wiring is less invasive than underground wiring, but it needs to be carefully planned and installed to ensure safety and reliability. Remember, it's always important to follow the National Electrical Code and local electrical codes when installing electrical wiring. These codes are designed to protect people and property from electrical hazards. If you are not familiar with electrical codes, it's best to hire a qualified electrician to do the work. A qualified electrician will know how to install electrical wiring safely and in compliance with all applicable codes. Ignoring electrical codes and using unapproved materials can have serious consequences, including electrical shocks, fires, and property damage. Don't take shortcuts when it comes to electrical safety. Always use approved materials and follow established electrical codes and best practices. Let's further elaborate on the approved methods for underground electrical wiring, focusing on the specifics of conduit types and installation techniques. When selecting a conduit, several factors must be considered, including the type of wiring, the environment, and the potential for physical damage. Rigid metal conduit is generally used in areas where the wiring needs maximum protection. This conduit is made of thick galvanized steel, providing excellent resistance to corrosion and physical damage. It's commonly used in industrial settings, commercial buildings, and outdoor applications where the wiring might be exposed to harsh conditions. The installation of rigid metal conduit involves threading the conduit and fittings together. Special tools are required to cut and thread the conduit, ensuring a secure and watertight connection. Intermediate metal conduit is a lighter weight alternative to rigid metal conduit. It offers similar protection but is easier to bend and cut. Intermediate metal conduit is often used in residential and commercial applications where the wiring needs good protection but doesn't require the maximum protection of rigid metal conduit. Electrical non-metallic tubing is a flexible conduit made of plastic. It's lightweight, easy to install, and resistant to corrosion. Electrical non-metallic tubing is commonly used in residential wiring, particularly in walls and ceilings. However, it's not suitable for direct burial or for use in areas where it might be exposed to physical damage. When installing underground conduit, it's important to bury it at the proper depth. The National Electrical Code specifies the minimum burial depth for different types of conduit and wiring. The depth depends on factors such as the voltage of the wiring and the type of soil. For example, direct burial underground feeder cable typically requires a burial depth of at least 24 inches, while conduit encased in concrete might require a shallower depth. It's also important to properly support the conduit to prevent it from sagging or shifting. Conduit support should be spaced according to the manufacturer's instructions and the requirements of the National Electrical Code. When running conduit through a building, it's important to seal any openings around the conduit to prevent the entry of water, dust, and pests. Sealing compounds and specialized fittings are available for this purpose. In addition to conduit, there are other approved methods for underground electrical wiring. Direct burial cable is a type of cable that's designed to be buried directly in the ground without the need for conduit. Direct burial cable has a tough outer jacket that protects the conductors from moisture and physical damage. However, direct burial cable still needs to be buried at the proper depth and protected from sharp objects. Another option is to use a cable in a duct. This involves running the cable through a plastic or metal duct that's buried in the ground. The duct provides additional protection for the cable and makes it easier to replace the cable if necessary. When working with underground electrical wiring, it's essential to take precautions to avoid damaging underground utilities. Before digging, always call the local utility companies to have them mark the location of underground cables, pipes, and other utilities. This will help you avoid hitting them with your digging equipment. If you do accidentally damage an underground utility, immediately call the utility company and report the damage. Do not attempt to repair the damage yourself, as this could be dangerous. Electrical safety is paramount when working with electrical wiring. Always disconnect the power before working on any electrical circuit. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you're not comfortable working with electrical wiring, hire a qualified electrician to do the work. A qualified electrician will have the knowledge, skills, and experience to install electrical wiring safely and in compliance with all applicable codes. Let's further clarify the importance of proper grounding and bonding in electrical systems, particularly when dealing with underground wiring. Grounding and bonding are essential safety measures that help to prevent electrical shocks and minimize the risk of fire. Grounding refers to connecting the electrical system to the earth, providing a path for fault current to flow back to the source. This helps to trip circuit breakers or fuses, quickly shutting off the power in the event of a fault. Bonding refers to connecting all metal parts of the electrical system together, creating a low impedance path for fault current. This helps to equalize the voltage between different metal parts, reducing the risk of electrical shock. In underground electrical systems, grounding and bonding are particularly important because the earth can act as a conductor. If there's a fault in the wiring, the fault current can flow through the earth, potentially causing electrical shocks to anyone who comes into contact with the ground. To ensure proper grounding and bonding, the National Electrical Code requires that all metal conduit, metal enclosures, and metal equipment be bonded together and connected to a grounding electrode. The grounding electrode is typically a metal rod or pipe that's driven into the ground. The size and type of grounding electrode depend on the size of the electrical system and the type of soil. In addition to the grounding electrode, the National Electrical Code also requires that a grounding conductor be run with circuit conductors. The grounding conductor is a wire that's used to connect the metal parts of the electrical system to the grounding electrode. The size of the grounding conductor depends on the size of the circuit conductors. When installing underground electrical wiring, it's important to properly bond all metal conduit, metal enclosures, and metal equipment together. This can be done using bonding jumpers, which are short lengths of wire that are used to connect the metal parts together. The bonding jumper should be sized according to the requirements of the National Electrical Code. It's also important to ensure that the grounding electrode is properly installed. The grounding electrode should be driven into the ground to a depth that ensures good contact with the earth. The connection between the grounding conductor and the grounding electrode should be made using a listed connector. In addition to grounding and bonding, it's also important to protect underground electrical wiring from physical damage. This can be done by burying the wiring at the proper depth and by using conduit or other protective measures. The National Electrical Code specifies the minimum burial depth for different types of wiring. The depth depends on factors such as the voltage of the wiring and the type of soil. It's also important to avoid running underground electrical wiring near trees or other objects that could damage the wiring. Tree roots can grow into the wiring and cause damage, and heavy objects can crush the wiring. If you're not sure how to properly ground and bond an underground electrical system, hire a qualified electrician to do the work. A qualified electrician will have the knowledge, skills, and experience to install the system safely and in compliance with all applicable codes. Let's discuss surge protection for electrical systems, particularly those involving underground wiring, which are more susceptible to certain types of surges. Surge protection devices, or SPDs, are designed to protect electrical equipment from voltage spikes, which can damage or destroy sensitive electronic components. Voltage spikes can be caused by a variety of factors, including lightning strikes, power grid switching, and even the starting and stopping of large electrical appliances. Underground wiring is particularly vulnerable to surges caused by lightning strikes. When lightning strikes the ground, it can create a surge of electricity that travels through the earth. This surge can then enter the electrical system through the underground wiring. To protect against surges, it's important to install SPD at the main electrical panel and at individual electrical circuits. SPD work by diverting the surge of electricity away from the sensitive electrical equipment and into the ground. There are different types of SPD available, each designed to protect against different types of surges. Type 1 SPD are installed at the service entrance of the building and are designed to protect against large surges caused by lightning strikes or power grid switching. Type 2 SPD are installed at the main electrical panel and are designed to protect against smaller surges caused by internal sources, such as the starting and stopping of appliances. Type 3 SPD are installed at individual electrical circuits and are designed to protect against very small surges that can damage sensitive electronic equipment. When selecting SPD, it's important to choose devices that are rated for the voltage and current of the electrical system. It's also important to choose devices that are listed by a recognized testing laboratory, such as Underwriters Laboratories. The installation of SPD should be done by a qualified electrician. The electrician will ensure that the devices are properly installed and grounded. In addition to installing SPD, there are other steps you can take to protect your electrical system from surges. Unplug electronic equipment during thunderstorms. This will prevent the equipment from being damaged by lightning strikes. Use surge protectors on sensitive electronic equipment. Surge protectors can help to protect equipment from smaller surges that might not be stopped by the SPD at the electrical panel. Inspect your electrical system regularly. Look for signs of damage, such as loose wires or corroded connections. Have a qualified electrician repair any damage immediately. Surge protection is an important part of electrical safety. By taking the necessary steps to protect your electrical system from surges, you can help to prevent damage to your equipment and reduce the risk of fire. Let's elaborate on the specific types of cables approved for underground use, focusing on their construction and applications. Several types of cables are specifically designed and approved for direct burial or installation in underground conduits. These cables are constructed to withstand the harsh conditions associated with underground environments, including moisture, temperature variations, and physical stress. Underground feeder cable is a common type of cable used for underground wiring. It consists of two or more insulated conductors surrounded by a tough outer jacket that is resistant to moisture, abrasion, and sunlight. Underground feeder cable is typically used for residential and commercial applications, such as wiring for outdoor lighting, pumps, and other equipment. Direct burial cable is another type of cable that is designed for underground use. It is similar to underground feeder cable, but it has an even more robust outer jacket that provides additional protection against moisture and physical damage. Direct burial cable is often used for applications where the cable is buried directly in the ground without the need for conduit. Mineral insulated cable is a type of cable that consists of copper conductors insulated with a mineral compound, such as magnesium oxide, and enclosed in a copper sheath. Mineral insulated cable is extremely durable and resistant to high temperatures, moisture, and physical damage. It is often used in harsh environments such as industrial plants and hazardous locations. When selecting a cable for underground use, it's important to consider the specific application and environmental conditions. Factors to consider include the voltage and current requirements, the type of soil, the depth of burial, and the potential for physical damage. It's also important to consult the National Electrical Code and local electrical codes to ensure that the cable is approved for the intended use. The installation of underground cable should be done by a qualified electrician. The electrician will ensure that the cable is properly installed and protected from damage. The cable should be buried at the proper depth, and it should be protected from sharp objects and rocks. The cable should also be supported properly to prevent it from sagging or shifting. When splicing underground cables, it's important to use waterproof connectors and splices. These connectors and splices are designed to prevent moisture from entering the cable and causing corrosion. It's also important to properly seal the ends of the cable to prevent moisture from entering the cable. Underground cables should be inspected regularly for signs of damage. Look for cracks, cuts, or abrasions in the outer jacket. If any damage is found, the cable should be repaired or replaced immediately. Proper selection, installation, and maintenance of underground cables are essential for ensuring the safety and reliability of electrical systems. By following established electrical codes and best practices, you can help to prevent electrical shocks, fires, and property damage.